Alrighty, so we're going to welcome NJCCIC for their presentation coming up, and would you folks like to introduce yourselves?
Hello, everybody. My name is Trent Myers. I was born and raised in North Jersey. My sort of foray into cybersecurity was probably around 10 or 11, downloading like fake RuneScape private servers and things like that. And I break my computer, and then I realized that, computers can actually do things that they're not really supposed to do. And that was really kind of eye-opening to me. So then for high school, I started programming classes, and then for college, I actually went here to NJIT. So pretty cool to be back, even though we only work like 3 blocks that way. It's cool. I don't really find myself on campus so much, so cool to be back. I'm Trent Myers. Yeah.
Hey everyone, my name is Sana Kim. I am a SOC analyst here at NJCCIC. The way I got into cybersecurity is through, in high school I had the exact opposite path, where I was trying to become a doctoral nurse, and now I took a comp sci elective course, and it was fascinating, so I decided to pursue computer science instead at Rutgers, and I graduated in 2021, and I was able to intern at the NJCCIC for a semester, and then I decided that maybe working for the NJCCIC here would be great, and I enjoyed it, so I was thankfully offered a full-time position here, so that's how I'm here.
Hey everybody, my name is Celine Carolino. I started in criminal justice, and I got into cyber because I took a digital forensics course. I've always been kind of interested in, and then all of my friends are always asking me to fix their computers and stuff like that. So I was like, oh hey, maybe this is interesting. And then I switched to a digital forensics program at the University at Albany. I applied for the NJCCIC internship and got it, and I've just loved it ever since. So I've been working full-time there since last summer in the SecOps division, security operations, mainly doing SOC team as well as incident response and digital forensics.
Hey everyone, my name is Swati Parthiba, and I'm a security analyst with NJCCIC. I actually started my path in security back in 2019 when I was a high school intern with NJCCIC, and I'm now working part-time on the SecOps team while I'm also finishing my computer science degree at Cornell, planning to graduate in May.
Okay, so without further ado, we will get started with our presentation. So who are we? We're the NJCCIC. The NJCCIC was established in 2015. It's organized under the New Jersey Office of Homeland Security and Preparedness. And as a whole, we are responsible for security operations for the executive branch of New Jersey. And for people who may have fallen asleep during social studies class, the executive branch is, Motor Vehicle Commission, Department of Transportation, Department of Education, things like that.
Awesome. And now we'll introduce what we are, or what we do in the NJCCIC. So Trent and I, and Swati and Celine that you heard on Discord, are all members of the Security Operations Center, the SOC, at the NJCCIC. And our primary goal is to detect suspicious or malicious activity and promptly remediate them. And the emphasis is on detect, because our mindset is to assume that our networks has already been compromised, or that there's already a threat within our environment. So our goal is to minimize damage from that compromise and also reduce risk to an acceptable level. And I guess summarizing that into a single sentence would be our ultimate goal: to reduce the probability of impact on the organization, on the NJCCIC, on the Garden State Network, which is the New Jersey's overall network in the state government, from any cyber event. And I'm not sure if you can see that figure here. It might be a bit too small, but I put down this diagram because I thought it summarizes what the NJCCIC, or what the SOC, does pretty well. And in essence, it comes down to the 5 central steps that you see in the middle box there: collection, detection, triage, investigation, and incident response. So, and the reason that I organized this diagram this way is because I think of the SOC as a function that takes 2 inputs and comes out with an output. So if we have high quality threat intelligence and high quality internal monitoring logs, whether that be from the network traffic or endpoints, Then we would have a high quality output, which would be the form of an accurate identification and remediation of incidents. And we'll go through all of these steps as we present and as we go on through this presentation. But you see, this is a bit of a busy diagram, and that's because there's so many things that are involved into making a SOC, or a Security Operations Center, successful. And that ranges from all the way from detection engineering to forensics to vulnerability management. So there's a lot of components that are needed to make sure that the SOC team works as intended. And so the point of this presentation, we thought it'd be interesting if we walk through our investigation into a real-world detection that we had on our network and on our environment. So we'll first start off with the collection part, where we'll go into how we collect and how we use the logs that we have from all of our environments, and also how we collect and how we research threat intel and how that helped attribute this activity that we picked up on onto something called bootloader or bootgate. And then next on, we'll go on to how we detected that suspicious activity, go on to investigate whether this was a true positive or a false positive, and then finally, once we deemed it to be true positive, what we did to remediate the actual event. So there's a lot of information online, and if you just go on to security companies or security researchers' blogs, they have a treasure trove of information of the most recent threat intelligence or whatever they've discovered or uncovered. So if you want to get your hands wet and get some experience in that, and I feel like that's a great way to actually get into it. But for us, I think the threat intelligence is one of the biggest inputs of the SOC because it helps us keep up to date on the most recent threats and the most recent TTPs, the tactics, techniques, and procedures of threat actors so that we know what to look out for in the network and in our environment that can possibly indicate to us, hey, this is a threat that's in our network and we should actually do something about it. So here you see 4 security articles from Mandiant, Trend Micro, and I think BlackBerry too, all about bootloader. And you can just easily search these up online. So I'll set the stage for our presentation by explaining what bootloader is so that our presentation kind of makes sense and our investigation into it makes sense as well. So bootloader can be thought of as malware that's used as a first stage downloader for additional payloads. In other words, if you have bootloader on your system, then it'll go out, reach out, and try to download additional malware and additional payloads. And the way that it gets onto your network or onto your system is through something called search engine optimization poisoning. So in this example from Sophos, a user looked up, hey, do I need a party wall agreement to sell my house on Google? And I don't know what a party wall agreement is exactly. I think that's something where it's a document where if you have a shared wall with another neighbor and you're trying to sell your house, then you might need that document. But it's a legitimate thing that you might actually ask, or be curious about, and you need that document. So you search that up on Google, and the first search result that you see has all the keywords that you just looked up for. So you blindly click on that search result, and you see a forum, and there's an answer there with a link, hyperlinked, to some site, but you click that link, it downloads a zip file, you don't think much about it, you extract it, and you click on, hey, the file name, do I need a party wall agreement to sell my house? Think that it's a PDF. But no, it's really a JavaScript file. It runs the bootloader script, which performs a brief amount of recon onto your system, and then tries to download additional payloads. So what you see here isn't a legitimate forum. It's a fake forum that's on a legitimate site that has been compromised by threat actors. And the reason that it showed up as the first Google search result here was because threat actors try to match all of their keywords and relevancy to make sure that the intended targets actually see that and that it's on the top of that Google search result to actually visit and click and download the malware. So with that out of the way, we'll actually go on to our first step of our collection phase, which is the log collection. And this is also an important part of the SOC, because without any logs, we don't have any visibility into the environment or what's actually happening within our network. So the first type of logs that we collect is network traffic, and that could be in the form of firewall logs, service logs like DNS requests, SSH connections, things like that. And then we also have endpoint and application activity logs, so that we could know specifically what type of process was running on a host at a specific time duration. And all of those logs combine to terabytes of logs, of data. And obviously we can't go through every single log ourselves to try to organize that and try to see and detect suspicious activity. The best way to do this, we use something called a SIM, a Security Information and Event Management tool. This aggregates all of our logs into a single source, into a single location that's easier and simpler and much quicker for us to analyze. And of course, that's not the only place. We can also, all these logs are stored in places like GCP Cloud, Google Cloud Platform, or Amazon, AWS. And so we can access all those logs directly from those cloud platforms that we store these logs in, and perform our own visualizations and try to create our own analyses directly as well. And so, as an example, if we wanted to see a host visiting google.com, we'll see in the SIM, within the same time duration at a single location, the host making a DNS request to google.com, the firewall logs indicating that the connection was allowed, and the specific browser that the user was using to actually browse to google.com. But even with a SIM, there's still so many different logs that we can't go through every single log to see what is suspicious activity or not. And for that, we need detection rules. We need to engineer our own rules to classify whether this activity is suspicious or not. And for that, I'll hand it off to Trent.
Okay, so as Sanook mentioned, we actually ingest like terabytes of logs, and obviously we can't have individuals combing through terabytes of logs. We're not going to find anything. So VirusTotal developed a language called Yara, which essentially allows an analyst to define interesting or suspicious behavior, and you can do it based on binary patterns or just straight textual patterns. And every time the logs match any of these Yara rules, it will trigger for you. Now, Google decided to take it a step further by developing Yara-L. It's essentially the same thing as Yara, but it combines all of your data sources. So we don't need a rule for our DNS logs, we don't need a rule for our endpoint security solution. We just need one rule that kind of incorporates everything. And you can see here in our example, this is the Outlook vulnerability, the zero-touch that shares your NTLM hash with the attacker's SMB server. So we defined some activity that we saw from logs that would be indicative of this behavior. And finally, we have just decided to show just another visualization of this is one of our rules that checks for. So many domains are visited on the New Jersey network that we can't go through and individually, as analysts, just determine which domain is legitimate or which ones are suspicious. So we rely sometimes on vendor classifications. So if someone is using Palo Alto and they notice that a site is malicious, they can report it to Palo Alto, and Palo Alto will share it with the rest of their customer base. So that's one way that we kind of rely on the community as a whole, as well as making, of course, our own rules. But here's a visualization that shows one of these detections. And now I'm going to hand it off to Celine to discuss a little bit further about how we make decisions about investigating further.
Thanks, Trent. So when we're thinking about a detection and kind of going over the events in our heads and the information that we have and the information that we don't have, we ask ourselves questions such as, has the detection left us with questions? Yes or no. If the detection has left us with questions and we need more information, then we'll move on to our next tool. So have our EDR tools provided us answers to those questions? If no, then often we will move to forensics and take an image of that machine so that we can get those answers to those questions and kind of make a determination of whether or not the user has been compromised. Is it a true or false positive? And a lot of the times, even if we don't answer yes to do we need more information, or if those EDRs tools have provided us with that information, a lot of the times it is still beneficial to learn more about the adversary. So I know a lot of the times we'll have a maybe like a phishing alert come in, and right away we can tell it's a true positive and it's a close and shut case, remediation's done already, but maybe it's something that we haven't seen before and we want to learn more information about it. Then it's worth taking an image of that machine and we can kind of get a deeper look into the machine and better understand the threat actor, and that'll help us in terms of future prevention, as well as creating rules and stuff like that to alert us of when it's in our environment again. You can go to the next slide, please. Thank you. So for our investigation tool, basically it is a tool that we call it a collector. We take that collector and we put it onto the target machine, the machine that has been potentially compromised, and that executable will run on that machine and collect important artifacts. And that's very vague, so I'll go into the kind of artifacts that it collects. It's a ton of information that is very relevant in a forensics investigation. One of the things that's pretty cool is it collects the volatile data, since we are collecting it on a live machine. And those of you that know forensics know how important volatile data is and how sometimes it's not possible to get it if that machine comes to us when it's turned off. So it'll collect the running processes that were running at the time that the machine was on, network connections, users logged in. Another cool thing is it'll categorize all of these things into different sections that are relevant to forensics and hopefully to your case. So malware persistence will include things like scheduled tasks and startup items. The user activity will pull information from the registry logs for user lockouts, failed passwords and stuff like that, along with those timestamps associated with the events. Another cool thing is metadata. So it'll take the information on the files and provide file hashes, file modification and creation dates, as well as giving you the option to actually export that file and further analyze it, say if you want to throw it into a sandbox or something like that. And additionally, with the file scanning, it's pretty cool because they have a malware scan feature. So it'll take that whole image and run all of the files in that image against over 50 yard rules, as well as a good list and a bad list within their environment on a global scale, as well as your own environment. So over time, you can kind of say like, okay, well, we identified that this file hash is bad, so let's add it into our system. And then for the next incident, if that comes up again, it'll flag it as bad. So definitely very cool, something very helpful to have. So, and with that being said, so there's so much information, so it's hard to know where to begin. And there's no guide really to really tell you for each different investigation, like, okay, this is where you begin every single time. Every single time you're going to start with a timestamp, or every single time you're going to start with the executable you found, the file hash. It's all going to depend on the type of incident you're looking at and what occurred during that detection. So there's a few different things I mentioned in here as the timeline of the incident. So if you know when that detection occurred, you can use a timeline feature that's in this tool and kind of search by that. So if we know the timeline of the detection, we can kind of throw that into our into the tool and then say, okay, this is when that happened. Let's look at what happened before and let's look at what happened after that. And you're going to see that's kind of what we did in the bootloader case. But before I move on to that, I just wanted to mention we also sometimes take the files that come from the case, and you can also search that within the tool and get more information on it. So also in this particular case, we were able to take the malicious file, very basically take the name of that, throw it into the tool, and then the tool tells us, okay, at this time, this file was associated with a scheduled task creation. And I will get into that on the next slide. So all of this information comes from, a lot of the information comes from the registry, local logs, file systems, and much more on the system. So one of the things I wanted to focus on was the data from the user's browsers. And something that I kind of forgot to mention before is it's also important when doing an investigation like this to get in touch with that user and figure out, okay, what were you doing at the time of this detection? Did you notice anything suspicious happening? Did you see the mouse moving around? Did you notice that there was a scheduled task that you didn't create? Oftentimes, in my experience at least, haven't seen the user observing anything like that. It's more like we get a detection and then we ask them about it. They're like, yeah, that maybe could have happened. So, but it's still good because they could have noticed something that you didn't at the time and then the tool didn't collect. And again, another important thing to note is not every user is the same. So if you're looking at the tool and it's saying, okay, this is suspicious, this is malicious, but that user is a test account or they do a lot of testing with malware and stuff like that, then that might be normal activity for them. And you can end up going down a different path and not even really looking at what's related to the detection, and which I will get into a little bit later. So going back to the user's browsers, for our case, we were able to narrow down a timeline by searching that initial malicious file that Sinuk mentioned in the beginning. And from here, we were able to pull the history file, which is located in the app data of your browser. So whether it's Microsoft Edge, Google Chrome, the tool takes that file and neatly parses it out for us for a better view. And we can kind of get an idea of where that file came from. So this is a screenshot of the timeline feature in the tool that I've been talking about. As you can see, there's a ton of information, but what I mainly want to focus on is at the top, you can see the first event is a URL visited, and it's Bing. And then followed by that, there's a website called PKI Vietnam, and it's referencing a document, New Jersey School Memorandum Agreement. And what's also cool is in the type column, it tells you what action the user did when they were on that site or when WScript was running. So URL visited, file created, file downloaded. It'll tell you if they filled out a form on the site, if they downloaded a file from that site. So as you can imagine, that's extremely helpful when trying to figure out, kind of just paint a picture of what happened with this user. So they started off by doing a Bing search, and then on the Bing's result page, they found that website, and we assume they were looking for that document, New Jersey School Memorandum of Agreement. So they clicked on the site, and as you can see, it says file created, that zip file downloaded, that file was then downloaded, unzipped, and file modified, and then the program was run. Sorry, I was screwing out for a minute. And then from there, we can see the scheduled task being created, pointing to that unzipped file. So it's very cool and a lot of good information coming from this. And I will show you, next slide, please. And so this is just an example of when we export the files coming from that timeline. So for example, that first Bing URL, when you look into the description of where the tool pulled that from, it'll tell you, hey, we pulled this from the history file of Microsoft Edge. So now we know that the user was using Microsoft Edge, and we can actually export that history file and take a deeper look into those URLs, which is exactly what we did in this scenario because we didn't have the full URL, and we were able to grab the whole thing, which is pretty cool, and it helped us out a lot. And so that brings me to how can we remediate the device? And there's a couple different routes that we can take. The first one, manual remediation, I wouldn't say is ideal, depending on the scenario. It's basically we'll identify those malicious files and those scheduled tasks and delete them, make sure there's no remains left from there, remove the malicious registry keys created. And as I said, that takes longer, but if you're in a scenario where you can't afford to reimage the entire machine because of potential data loss, then that's the best bet, and it still works. So, but in this case, we just reimaged the entire device, which was faster. Did result in some data loss, but luckily with things like OneDrive and stuff like that, we can often restore the files. So as you can see, it takes a lot of work from detection all the way to remediation. And there's a lot of steps along the way, a lot of different areas and people and moving parts. But one way we can try to kind of ensure that we don't get bogged down by terabytes of logs is automation. And I'm going to turn it over to Swathi to discuss our automation efforts.
Great, thanks, Celine. So I'll be talking a bit about how we use automation in our incident response process in order to save time when we're actually responding to these alerts. So security automation is really about combining software development with cybersecurity in order to avoid having to do such manual tasks when investigating alerts. So this might be an interesting area to those of you who are studying computer science, for example, and want to apply that to security. So automation is important because sometimes the SOC may not have a lot of time to respond to an alert because of its severity, for example. So we can get incidents remediated a lot faster using automated processes. And in terms of what we actually automate at NJCCIC, here are a few examples, and I'll also go through some of these more in depth as well. So firstly, we have a process to automatically collect information from hosts. So this can be things like processes running on the system to browser extensions that are installed as two examples. And we also automated the process of creating tickets for our alerts as well. So when our detection rules generate an alert, we have a script that's set up to collect that alert and send the information to our ticketing platform for tracking. And finally, we also automated the process of searching open source intelligence sources by performing a process called enrichment of our alerts so that an analyst has more information as well as context when investigating an alert beyond just what the SIM provided us with. Next slide, please. So the first example I'll go through is a PowerShell script that we actually use pretty often to get installed browser extensions from a device. And a use case for why we would even want to do this or look at browser extensions is, for example, if we get an alert about abnormal network requests that are coming from Chrome, for example, it might not always be an actual user that are making these requests, but it could be a malicious browser extension that they have installed on their device and they don't know about it. And this is something that actually happens because it's possible for malware to unknowingly get on a system through a browser extension, because if the extension isn't verified by the web store, for example, it could be doing something malicious in the background, such as exfiltrating your data. So having a tool like this is really helpful, so we don't have to manually figure out what browser extensions are installed during an alert investigation. And here's just a screenshot of a snippet of the PowerShell script that I mentioned. If any of you have used PowerShell before, this might look a little familiar, but PowerShell is basically a scripting language used in Windows for task automation. And how this script works is it'll loop through system-level properties of the browsers that are installed, such as Chrome, Edge, and Firefox, and then get all of the extensions that are listed in the properties. And on the next slide is the output of what the script would look like when it's run on a system. So we get a list of the browser extensions that are installed on a host, as well as a link to the corresponding web stores as well. So that makes it really easy for us to just be able to click on that to get more details about who developed the extension and some other information as well. And the second example that I'll go through is a workflow that we developed to automate incident response actions. So we developed this form that can be filled out by analysts while they're investigating an alert, where they can specify common incident response steps, which includes maybe information that they want to collect from a host, actions they want to take on a host, and some other functionality that we have as well. So this is an example of how the form would look like while an analyst is filling it out. So at the top, they would fill out, they would specify the host that they're identifier value, and then select an action from the dropdown to actually take on that host. And some examples of actions that can be requested are removing files from a system. So for example, if a piece of malware is found, they can fill out this form to actually remove that from the system, and also running forensics tools as well. So a forensics tool, for example, is the one that was shown in the Goodlitter example. And then after the form is submitted, some automation takes place in the background, and then within a few minutes, the analyst would get an email that looks like this, that would contain the results of the action that they requested. So in this case, an analyst requested information from a host, which included the system event log and also what scheduled tasks are registered on the system. And these are also all sent as attachments, so they're more easily accessible during the investigation. So the benefit of this automation is that it saves the analyst a lot of time in the alert investigation process, since the alternative would be remotely connecting to the host, they're investigating, and then manually pulling all this information or performing those actions that need to be taken. So this can all be done by filling out a form, and the process can be completed a lot quicker than it would take to perform manually. And then on the next slide, this is just a high-level overview of how the automated response actions work. So on the left, we have the web form that the analyst would submit, and then that information submitted gets sent to our automation platform, which we develop some automated workflows that actually execute step-by-step how to complete each of the actions that we can request. And then behind the scenes within this automation platform, we programmed workflows to interact with our endpoint detection and response, or EDR solution, so that we can remotely make changes on hosts on our network. And the platform also calls AWS Lambda functions as well, where we execute Python code that will complete some of these actions. And then after the execution is all performed and done, we get an email that gets sent to the requesting analyst and also includes the results of the actions as we saw before. And we also include these in our alert ticketing platform as well, so we have all the investigation information all in one place and more easily accessible. So those are all of the topics that we wanted to cover with you all today, but we also just wanted to include some helpful learning resources as well if anyone's interested. So TryHackMe is a free platform that has a SOC analyst learning pathway, which covers a lot of the concepts that we actually talked about today. Additionally, certifications are also something that's really helpful to pursue. And the CompTIA trifecta, if any of you are familiar, A+, Network Plus, and Security Plus, is one that's recommended really throughout industry. And then finally, if you're interested in automation, Python is a super useful tool to know as well. So now I'll pass it over to Trent to wrap up our presentation.
Okay, thanks, Swati. So really to tie it all up and kind of put a nice bow on it, if you enjoy fast-paced work that kind of is always changing, if you enjoy having to learn on the job, and you enjoy being challenged almost every day, then a career as a SOC analyst, or at least cybersecurity in general, is almost definitely for you. So with that being said, we would like to spend any remaining time opening the floor up to any questions that anybody has. If not, we will be, or at least Sanook and I will be at the table right back there. If you want to come up and say hi afterwards, please do. Don't be shy. Yeah, the floor is yours.
We have a few questions in the chat here. So the first one is, how do SOC teams stay up to date on the latest threats and vulnerabilities?
So I can kind of piggyback off of John Hammond, which is, I think, the first and only time I'll ever be able to say that in my life. So I use a lot of things, like he said, Bleeping Computer, also like just Reddit, cybersecurity subreddit is a good one. Yeah, just things where come across things, just checking the news, you know. But yeah, those are my favorite resources. I don't know if Sanook has anything.
And I guess if you want to find more about it, about like the most recent vulnerability or most recent threat, then you can go to the security vendor or security researchers' blogs directly and try to read into the more technical and in-depth explanation on those. So that's also a good way to do that too.
Another one is, how do you think emerging technologies such as AI and machine learning will impact the future of cybersecurity and the work of SOC teams?
That's a really good question. We've already seen like things like ChatGPT using or even coming up with really convincing phishing messages, and we actually they can also be used to create detection logic as well. That's all available online. So that's definitely one component. It's another cat and mouse game where it's just never-ending race between the threat actors and the defenders. And yes, they're being used for different purposes, but that it definitely can be intertwined into our workflow. But I'm not sure if that answers that question adequately. Do you have anything to add? No? Okay.
What is one skill or characteristic that has most helped you be successful in the SOC analyst position?
So I would actually say that it's not even anything technical. It's more so the ability to work as a team, you know, and being able to share information with other people. And as you work in detection, if you uncover something new, you have to make sure that you're sharing that with your team because, you know, your team, you all get better together, right? It's all about upskilling together. And so, yeah, I think it's not even really a technical skills that are going to make you like a really good SOC analyst. It's more so the soft skills, being able to work as a team and being able to put things together.
I'd also just add like being flexible as well has been something helpful. I think as alerts come in, we might have to like prioritize different things in a week, have to stop working on a project like in 1 week because there was something more critical going on. So just like being able to context switch and go back and forth is something helpful.
And to add on to that, I would also say I learned to definitely ask questions, not be afraid to ask questions. Everybody's got their strengths and everybody has their weaknesses, and kind of like what Trent said, working as a team, it's a great environment for collaboration. And if something I don't know, Trent, Sanook, or Swathi might know, and vice versa. So definitely don't be afraid to ask questions.
Guys, the next question is, what is the work-life balance like, both in cybersecurity and at NJCCIC?
So the only full-time job that I've had in cybersecurity is at the NJCCIC, and I can say that very confidently because it's a state job. The separation between work and the rest of your life is actually very well delineated. I don't find myself really doing work after 5 p.m. if I, you know, unless I want to, you know. So yeah, I can't speak for really anything outside of the NJCCIC as I don't have experience in other, you know, especially in the private sector. But yeah, that's from my experience. It's a very good balance.
Does NJCCIC work in tandem with both the private sector and other public sector cybersecurity agencies, or is it more just you guys?
So the NJCCIC does work with other private sector agencies or private sector organizations, I suppose, in New Jersey. We have a cyber threat outreach and partnerships division, and they handle a lot of the outreach, and they do actually a really, really good job. So yeah, it's not just restricted to New Jersey state agencies. You know, we try to get our hands as wide as possible.
What is something that you guys are excited for that's a development or a trend in the cybersecurity industry for the future?
I've got one. I also going back to that emerging technologies question too. How AI is being applied towards cybersecurity as well. So there's also something called C2 domains, where it's command and control domains, where threat actors try to either contact or exfiltrate data from a host that they've infected. But they've got to have a certain domain name to actually, or a certain way to reach their attacker-owned server. And identifying those domains is really difficult. But there's something like, there's recent papers that are published on how to identify these C2 domains based on machine learning algorithms, and trying to compare it with how they compete with, I guess, to detect if a domain's been generated through a domain generation algorithm, DGA, which has some randomness and items like that. So that's definitely a fascinating and exciting field to look forward to in the future, and hopefully to get a hands-on experience with in the future.
All right, thank you. This is our final question. Trent, this is for Trent. What courses at NJIT would you say were most relevant to your current work experience?
That's a good question. I think a lot of the intro to networking ones are good. Just to really, the internet is entirely based off of networking, right? So even if you only have a solid grasp on the fundamentals, that would really bring you very far. Another thing that I really enjoyed that helped kind of cement my joy for cybersecurity was taking computer forensics with Poppenweimer. I don't know if he's still a professor here. But that is an incredible course, and you learn a lot from that. Not so much for SOC analysts, but that's for more of like incident response things. But yeah, great course. Database management and administration has helped with learning like database schemas and things like that. But yeah, aside from that, I can't really say, but I would say far and away my favorite class was the computer forensics course. Okay, so if that's the last question, I'd like to thank everyone for giving us your time. And again, Sanook and I will be sitting right back there. If you want to come say hi, don't be shy. And next up will be our colleague, Andrew Garcia, with a really, really cool presentation on multi-factor authentication bypass. So definitely stay tuned for that. It should be really cool. Thanks, everybody.